This is a lesson for how to find an angle when a trig function value is given. First thing we want to do is find the reference angle, and we're going to do that by entering the inverse trig function followed by the absolute value of the given trig ratio. And this is the important part here, to find the absolute value, because keep in mind our reference angle is always between 0 and 90. So essentially we always want to find our reference angle in quadrant 1 even if our angle isn't in quadrant 1. So this is just to find our reference angle. Then based on the sign of the given value, we're going to determine which quadrants we're in. And again, that's going back to our little diagram on the left. And everything or all were positive in 1, sine was positive in 2, tangent was positive in 3, and cosine was positive in 4. So again, we said that technically each trig function is positive in 2 quadrants. So each trig function is positive in 2 quadrants. And so we're going to get 2 answers for each one of these if we're working backwards. If we're given a ratio, we can go backwards and we're actually going to find 2 angles that would produce that ratio. And then knowing that, we're going to find the 2 angles, one in each of the quadrants we found, and those are going to be our answers. So let's look at an example. So anytime we are given sine theta, cosine theta equals a number and asked to find theta, anytime we see this word find theta, we know that we're going to have to go through this process. In this first case here, we have sine of theta is equal to 0.3684. So first step is we are going to find the reference angle, which is going to be the sine inverse of 0.3684. And this again is just the reference angle. So we'll type that in. We hit second, sine 0.3684. We hit enter and we get a reference angle of 21.62. It says to the nearest tenth of a degree, so we'll just round to 21.6 degrees. So that's our first step. Our second step is to say, okay, well, this number here is positive. So 0.3684 is positive. So sine is positive in quadrants 1 and 2. So that's our second step. And then our third step is to find the angles in these 2 quadrants. So we're going to say in quadrant 1, we're lucky our reference angle is our angle. So theta is just 21.6 degrees. In quadrant 2, however, again, remember, so we have our angle here is theta, and then we have our reference angle alpha. So we want to find this angle, we'll call it theta 2, because we're in quadrant 2. Now, again, we're moving backwards off of 180. So in quadrant 2, theta 2 is going to be 180 minus our reference angle, 21.6. And we end up with 158.4 degrees. So these are the 2 angles that will produce the ratio 0.3684. Those 2 angles will give us that correct ratio. Try another example. Let's try cosine of theta is equal to negative 0.105. Again, we're rounding to the nearest tenth of a degree. First step, and this is where we need to be careful, even though this is negative here, to find the reference angle, we are going to take cosine inverse of the positive value or the absolute value of 0.105. Then we come out with an angle of approximately, so we plug that in, we take cosine inverse of 0.105, and we end up with approximately 84. I'm going to write the 2 decimal places though, even though it says to the 10th. We end up with 83.97 degrees. And I'm going to show you real quick, if we had kept that negative, then we would have said cosine inverse of negative 0.105, and we would have found that this is 96.03, which is the supplement to this, which is the angle in quadrant 2 that we need, but then it would have been difficult to find our angle in quadrant 3. So Again, if we think about where cosine is positive, all students take calculus. Cosine is positive in 1 and 4, so it is negative in 2 and 3. So those are the quadrants that we want to look in. And so then our third step in quadrant 2, we have an angle of theta is equal to, again, we're coming back off of 180, so it's going to be 180 minus 83.97, which was our 96.03 that we saw on the calculator. And in quadrant 3, we're coming forward off of 180. So in quadrant 3, we're actually going to have 180 plus our 83.97, which is going to come out to be 263.97 degrees. So again, if we had wanted to check these, we would say, okay, we want to take cosine of 96.03. If we do that, we get negative 0.105, which is what we're supposed to get. And if we do cosine of 263.97, we end up with that same number, that negative 0.105. So either way, either of these angles would produce the same ratio or decimal. So I'm going to do one more example here with you, and then we are going to have you work on one on your own. This last one deals with cosecant, and remember that cosecant of theta is the reciprocal of sine theta. So we're going to need to use sine inverse on this one. So first step is going to be sine inverse, and then we take the reciprocal of this, and we still take the positive value, so 1.913 is positive. And if we do that, we say, okay, sine inverse of 1 divided by 1.913, we end up with 31.5 degrees. Again, this is our reference angle alpha. Second step, we need to find our quadrants. We can draw our little figure again over here. So this time we were talking about sine, cosecant and sine would have the same positive, negative values. So sine is positive in 1 and 2. So our answers we're looking for on 3 and 4 because our ratio is negative. So we'll write that down. We want quadrants 3 and 4. And then third step, we'll actually find these angles. So in quadrant 3, theta is going to be, again, we're moving forward off of 180. So we're going to add to 180. And we end up with 211.5 degrees. In quadrant 4, we are coming back off of 360. So 360 minus 31.5 is going to come out to be 328.5 degrees. And these are our two angles. Again, we could check this. If we take 1 divided by the sine of 211.5 degrees, we end up with negative 1.913. A little bit of an issue with rounding there, but not too bad. And for the other one, 1 divided by the sine of 328.5 degrees. Again, same number here. So in this case, we are okay. These are the two angles that we needed. So I'm going to make an example here for you to work on. Given tangent of theta is negative 1.284, I want you to go through and find theta. Again, just as we did before, you're going to find two angles and round to the nearest tenth of a degree. So pause the video here and work through this example. So you should have found that tangent was negative in quadrants 2 and 4. And so in this case, you should have found the angles of 127.9 degrees and 307.9 degrees. So this concludes the video for section 10.2. Please go online and complete the homework for this section, and then complete the quiz for Chapter 10.